Okay, in this lesson, we're going to look at terms used in describing waves. Terms used in describing waves. So basically, we're going to look at 5 terms that are used in describing waves. We have the amplitude, wavelength, cycle, frequency, and period. These are the 5 basic terms that are used in describing waves, right? So we're going to take the first one, which is the amplitude. Amplitude is the maximum displacement of a particle from its rest position. It is the maximum, right? The maximum displacement of a particle from its rest position. It is represented as A and it is measured in what? In meters. So if you look at this wave, this is the rest position. This horizontal line here is the rest position. That is the rest position. So the maximum means highest, greatest. So the maximum displacement of this wave from this rest position is what is referred to as what? The amplitude. So this is the maximum displacement from the rest position. This is the maximum displacement from this rest position. And so this is referred to as the amplitude. This is the amplitude. This is also the amplitude because it is the maximum displacement from the rest position, right? So we have 2 forms of amplitude. We have the crest. Crest is the maximum upward displacement. So the maximum upward displacement from this rest position is referred to as what? Crest. Crest is the maximum upward displacement. So this is the crest, this is a crest, this is a crest, this is a crest, this is a crest. It is the maximum upward displacement from this rest position. Then we have trough. Trough is the maximum downward displacement from the rest position. So the maximum downward displacement, this is trough, this is trough, this is trough, and this is trough. It is the maximum downward displacement from the rest position, right? So trough is the maximum downward displacement from the rest position. So the crest and the trough are the amplitude. They are collectively referred to as what? The amplitude. So having known that, let's dash to the next term used in describing a wave, which is the wavelength. Wavelength. So what is wavelength? Wavelength is the distance between 2 successive crests or 2 successive troughs, right? The crest is what? The maximum upward displacement. So this is a crest, this is a crest, this is a crest, this is a crest, this is a crest. So the distance between 2 successive crests is referred to as the wavelength. So from here to here is the wavelength. From here to here is another wavelength. From here to here is another wavelength. From here to here is another wavelength. So it is the distance between 2 successive crests or 2 successive troughs. So this is a trough, this is a trough, this is a trough, this is a trough. So the distance between 2 successive troughs is referred to as what? The wavelength. So the wavelength is represented as this lambda, and it is measured in what? In meters. So the distance from here to here is your wavelength, which is measured in what? In lambda. The distance from here to here is your wavelength, and it is measured in what? In lambda. It is represented as lambda and it is measured in meters, right? The distance from here to here is your wavelength, represented as lambda, and it is measured in what? In meters. So this is very, very important. Then the next term used in describing a wave that you should know is cycle. So a cycle is a complete to and fro movement or oscillation of a vibrating body. It is the to and fro movement of a vibrating body, the complete to and fro movement or oscillation of a vibrating body. So if we use this wave to describe a circle, the distance from here, as the body moves from here, as the wave moves from here to here and then back to this plane, this is a cycle. So how do I know a cycle? A cycle usually consists of a crest and a trough, right? So from here to here is one cycle. So from this point to this point is one cycle. From this point to this point is another cycle. Like I said, A cycle usually consists of one crest, one trough. So from here to here is another cycle. From this point to this point is another cycle. So just know the definition of the cycle, that it is a complete to and fro movement or oscillation of a vibrating body, right? So having known that, let's look at the next term used in describing waves, which is frequency. So frequency is the number of complete vibrations or cycle that a particle make in 1 second. So let's take this as a wave, right? Yeah. So frequency, like I said, is the number of complete vibrations or the number of complete cycle that a particle make in 1 second. It is represented as F and it is measured in hertz. Very important. So it is the number of complete cycles or vibrations that a particle make in 1 second. So the number of cycles that this wave make in 1 second is referred to as what? The frequency. While the period is the time taken to make one complete oscillation or cycle. So a cycle usually consists of a crest and what? A trough. So from here, from this position to this position is one cycle, right? This is one cycle. So the time taken to make one complete cycle is what is referred to as what? The period, and it is represented as t and measured in what? In seconds. So the time that it will take the wave to make one complete cycle, that's to complete the wave from here to here, it is referred to as what? The period. Again, the time taken to make one complete oscillation or cycle is referred to as what? The period. While the frequency is the number of cycles that the particle make in 1 second. So having known all this, it's very important that we know the relationship between frequency and period, right? So here we're looking at the relationship between frequency and period of a wave. So the relationship is F, which is frequency, is equal to 1 all over T, which is the period, or T, which is the period, is equal to 1 all over F, which is the frequency. So this is the relationship between the frequency and period of a wave. So for instance, if I say a wave has a frequency of 2 Hz, let's say the frequency is equal to 2 Hz, and I ask you to look for the period, you're simply going to look for the period like this, that your t is equal to 1 all over f. That's the relationship between frequency and period of a wave, right? So my t will be equal to 1 all over 2, and 1 divided by 2 will be equal to what? 0.5 seconds, right? So if I give you the frequency, you can look for the period of a wave using this relationship, right? So also, if I say the period of a wave, if the period of a wave t is equal to, let's say, 4 seconds, find the frequency. So you should know that the frequency is equal to 1 all over t, right? F frequency is equal to 1 all over the period. So if f is equal to 1 all over t, my f will be equal to 1 all over 4, right? Which is this 4 seconds. 1 divided by 4 will give us 0.25 Hz, right? So it's very important that you know the relationship between the frequency and period of a wave, and this is the relationship. F is equal to 1 over t, or t is equal to 1 over f, right? So having known this, let's dash to the next term used in describing a wave, which is the wave velocity. So the wave velocity is the displacement traveled by a wave in a second. It is the displacement traveled by a wave in a second. So wave velocity v is equal to lambda, which is the wavelength, over the period, which is time, right? So my lambda is what? The wavelength. Is wavelength. We've looked at it before, and t is the time or the period, right? Then we can also have v is equal to, which is velocity, is equal to f lambda, right? Where your f is the frequency of the wave, and your lambda is what? The wavelength. So these two formulas, you must take note of it. That is very, very important. V is equal to lambda all over T, or V is equal to F lambda, right? So let's look at this question. A source of sound produces wave in air of wavelength 3.42 meters. If the speed of the sound in air is 330 meters per second, what is the period of vibration? Again, I read, a source of sound produces a wave in air of wavelength 3.42. So the first thing that you want to do is to fish out your parameters, right? So we have been given that a source of sound produces waves in air of wavelength 3.42 meters. So the wavelength lambda is given as what? 3.42 meters. If the speed of sound in air is 330 meters per second, so we are given that the velocity is equal to what? 330 meters per second. What is the period of vibration? What is the period, which is t, of what vibration? So how would you solve this given these parameters? So you would have to look for a formula that connects your wavelength, velocity, and time. So the formula that connects it is V is equal to lambda all over T. Wavelength all over what? The period, which is time. So the velocity is what? The velocity is 330 meters per second. So that will be 330 meters per second is equal to 3.42, which is the wavelength, is given to us as 3.42 over the time, which is what you are looking for, over the period. So this is the same thing as 330 over 1. 330 divided by 1 is still the same thing as 330. So the next thing you want to do is to cross multiply, right? So if you cross multiply, 330 times t will be 330t is equal to 1 times 3.42 will be 3.42, right? So that's how we have this 330t is equal to 3.42. Then the next thing you want to do is to divide both sides by the coefficient of this t, which is 330. So my t will be equal to 3.42 divided by 330, right? So if you punch that in your calculator, 3.42 divided by 330, that will give you 0.01036 seconds. So this is our answer to this question. So the period of vibration is equal to 0.01036 seconds, right? So it's very simple and straightforward as well. So the next question that we have here is this. A wave has a frequency of 30 Hz and a wavelength of 40 centimeters. What is the velocity of the wave? A wavelength has a frequency of 30 Hz, so that tells us our f, which is the frequency, is equal to 30 Hz, and a wavelength of 40 centimeters. That tells us that the wavelength lambda is equal to 40 centimeters, right? So the SI unit of distance is meters and not centimeters. So the first thing that you want to do here is to convert these centimeters to meters, right? So knowing fully well that 100 centimeters is equal to 1 meter, then your 40 centimeters will be equal to 40 divided by 100, and that will be equal to 0.4 meters, right? So that's how we got these 40 centimeters to be 0.4 meters. Then the velocity is what we're looking for. What is the velocity of the wave, right? So what's the formula that connects frequency, wavelength, and velocity? So the formula that connects it is V is equal to F lambda, right? V is equal to frequency times wavelength. So V, which is the velocity, is equal to 30, which is the frequency, 30 Hz, times 0.4 meters, which is the what? Wavelength. So that will be 30 times 0.4. If you punch that in your calculator, that will give you 12 meters per second. So our velocity is equal to 12 meters per second. This is our final answer. It's very simple and straightforward too. So let's look at the last question that we have here. A transverse wave travels a distance of 80 centimeters in 10 seconds. It travels a distance of 80 centimeters in 10 seconds. If the distance between successive troughs of the wave is 4 centimeters, calculate the frequency of the wave. So what we're looking for is the frequency of the wave. Again, a transverse wave travels a distance of 80 centimeters in 10 seconds. So that tells us that our distance S is equal to what? 80 centimeters. So, and 80 centimeters, centimeters is not the unit for length. The SI unit of length is what? Meters. The SI unit of distance is meters. So I'll have to convert this 80 centimeters to meters. How do I do that? 100 centimeters is equal to 1 meter, right? Then 80 centimeters will be equal to 80 divided by 100, and that will be equal to 0.8 meters. So my distance, 80 centimeters, is equal to 0.8 meters, and t is equal to what? 10 seconds. A transverse wave travels a distance of 80 centimeters in 10 seconds. So the distance is 80 centimeters, which is 0.8 meters, and the time is what? 10 seconds. If the distance between successive trough, the distance between successive trough is referred to as what? The wavelength. I've explained that before, that if you have a wave like this, right, the distance between, this is a trough, this is a trough, the distance between two successive troughs is referred to as what? The wavelength, represented as what? Lambda. So if the distance between successive troughs of the wave is 4 centimeters, calculate the frequency. So we are given that the lambda, which is the wavelength, is equal to 4 centimeters. So if you convert that to meters, that will be 4 divided by 100, right? That will give you 0.04 meters. Then the frequency is what we're looking for. So how do we go about solving this particular question? We know that velocity v is equal to f lambda, right? Here we are given the lambda to be 0.04 meters. We have this, and then frequency is what we're looking for, and then we don't have the velocity, right? So we would have to look for velocity first. So you should know that your velocity is equal to what? Distance over time, right? So if velocity is equal to distance over time, that means my velocity is equal to, the distance is given as what? 0.8 meters. So that will be 0.8 divided by what? 10 seconds divided by 10, which is the time. So 0.8 divided by 10, that will give me 0.08 meters per second, right? So this is my velocity for the wave, 0.08 meters per second. So having gotten the velocity, the next thing I would want to do, so we now have what? The velocity, right? So the next thing I would have to do is to apply this formula. So v is equal to f lambda. So my velocity, I've already calculated it. It is 0.08 is equal to frequency times lambda, which is 0.04. Lambda, which is the wavelength, is what? 0.04 meters. So f times frequency times 0.04 will give me 0.04 f, right? So to make the f stand alone, I will have to divide both sides by the coefficient of this f, which is 0.04, right? So this will be divided by 0.04 divided by 0.04. So 0.04 will cancel out 0.04. So what we now have here is f. So that's how I wrote this f here, is equal to 0.08 divided by 0.04 divided by 0.04. So 0.08 divided by 0.04, that will be equal to 2 Hz. So my frequency for this wave is equal to 2 Hz. It's very simple and it is straightforward as well. So to prove that you understood this class very well, you would have to solve these three exercises.